Okay, sanibonani. Now, langiphethe ulokanje question 9 from a mid-year examination question paper ka 2018, excuse me. Ka 2018. So question 9 is all about electric circuits. In the description below uzothola links for amanye questions akhona in this question paper. Yeah. So lana-ke basiphe a circuit i-circuit yethu inama measuring instruments nama ammeter, voltmeter, ammeter as well, and then the circuit does also have a EMF, right? A switch value as well, right? So lana-ke it's going to be a two-part question. 9.1, we have two circuits, this one as well as this one. So asiphendule the question by reading the first, by doing the first one. Now, 9.1, but in the circuit diagram below, the battery has an unknown EMF and an internal resistance of 0.8 ohms. Okay, the 6 and the 4 are connected in parallel, and then this parallel connection is also connected in series with this 5.8 ohm resistor, and then across this one sibane voltmeter 1, across the parallel connection sibane voltmeter 1. Did I say voltmeter 1 la? This is voltmeter 2 and voltmeter 1. Okay, anyway, now then bese sibanani ni ammeter across uloganje 4 ohm, right? And then sibanani ammeter la, and then sibanani the internal resistance. So ngiyazi ukuthi some of the things bas mentionile lapha ku statement, I just ngifuna ukuzi-repeat just to make ama viewers wami aware. Right, now on the first question bathi 9.1.1 911 state Ohm's law in words. So in the description below ngizoyibhala as well ilokanje the law for this question, Ohm's law, but ngifuna ukumbhala as well before answering amanye questions. So the potential difference, Ohm's law to the potential difference across a conductor is directly proportional to the current in the conductor at constant temperature. So it's important to think in an ohmic circuit that temperature remains constant. Once the temperature goes up or down, the circuit no longer becomes ohmic, but even non-ohmic. But fortunately for us, we got grade 12 and even the lower grades where we discuss ama electric circuits corner, ama circuits wethu aba ohmic, where temperature is kept constant. Ama non-ohmic circuits uzowathola kuma high level university courses, but for thina sidila nama ohmic circuits. Now the reading on ammeter 2, this one basipha a value of 0.6 amperes when switch S is closed. Calculate the reading on voltmeter 1. So since this is a parallel connection and the voltmeter 1 is connected across 6 no 4 ohms, so ama parallel connections sithi ama current dividers, and then the voltmeter across it remain constant, meaning the voltmeter reading for 4 ohms as well as for 6 ohms is over the same, since this is a parallel connection. The only thing that gets divided it's only the current. So therefore i-current nayifika la kule node le, i-current iyadivider, kuzongena 0.6 amperes ngapha kuzongena x. We don't know what the value of current a flow through the 6 ohm resistor, but then the main takeaway la ukuthi i-current iyadivider kuma-parallel connections, but i-potential difference remains constant. So therefore, to calculate to V1, we can use the data for this branch, parallel connection. So therefore, since there's current lana, there's current 0.6 as well as resistance of 4 ohms. So therefore, in order to calculate to V1, we're going to use these two values. So 9.1.2, we have data of current 0.6 amperes, and then resistor of 4 ohms. What are we trying to calculate la? V1. Sifuna the value kabani ka V1. And then Ohm's law tini, the potential difference across is directly proportional to the current. In fact, let me get the formula, the actual one. Electricity. So resistance is equal to V over I. Resistance is equal to V over I. So therefore, tinasfuna V. So by cross multiplying line, making V the subject of the formula, we get something like V, it's I current times the resistance. So therefore, V1 can be calculated using this formula. Whether we substitute in this formula or this one, as long as uzoenza V the subject of the formula after substitution, in this case, uzotola the full mark. So V1, some calculator is I, current is 0.6 times the resistance of 4. Answer here 2 over 0.6 times 4 is equal to 2.4 volts. 2.4 volts. So the voltmeter reading on V1 is 2.4. So now the next question again. 3. Now sifuna the current through the 6 ohm resistor. So the 6 ohm resistor is in this parallel connections. Now since we know V1 and V1 will measure across the parallel connection. So if V1 will measure across this parallel connection, it means the potential difference la 4 na 6 is over the same, because this is a parallel connection. The only thing a divider in a parallel connection is what? Current. So V1 was about the same as lana. So for this branch, current for this branch ka 6, ngine voltmeter, ngine resistance, I can calculate to I using Ohm's law. So data is what? Resistance 6 ohm, and then ngifuna current, and then I also have a potential difference. A potential difference is the same value as above, it's 2.4 volts. Now ngifuna current again this time. Current, by manipulating this equation, current is going to be equal to V over R, cross multiply, divide by R both sides, we end up with something like I equal to V over R. Now the voltmeter is 2.4, the resistance is 6. The resistance is 6. So 2.4 divided by 6 is equal to 0.4, is equal to 0.4 current, it's amperes. Yeah, kushenga my units lapha with current. So now 9.1.4 equation 80, calculate the reading on voltmeter 2. Calculate the reading on voltmeter 2. Okay, again. All right. Maybe I can do a rough sketch now. Big parallel connection. The parallel connection, now resistance la. Now my resistor la. Now my resistor. So check out la. A parallel connection is divider only a current, but the voltmeter reading or the potential difference it remain constant in a parallel connection. Then in series, what gets divided in the potential difference? It's only the potential difference, but the current it remain constant throughout. So meaning the current A passes through resistor 1 and 2 in a series connection. In a series connection, in the current. So the current A measure la nala is over the same, but the only thing a divider series connection is the potential difference. That's why I'm a series connections with a potential difference divider. I'm a parallel connections, I'm a current divider. So bega in this question, in this question, siyabona ukuthi lana especially la ku 9.1.4 bathi calculate the reading on voltmeter 2. So in order to calculate to V2 ngidinga i-current flow through the 5.8, and the 5.8, as I've mentioned earlier, the 5.8 is connected in series with the parallel connection. So therefore i-current from the 6 and the 4 branch na recombine. I'm sure the conventional current it move from the positive terminal all the way up to the negative terminal. So your flow from is a flow anti-clockwise. So na isuka la iza la kule node ya divide the current lana sithola 0.4 amperes ngapha sithola 0.6 iflowa ngapha iflowing ngapha easy, and then at this node iphindi yenzani ya recombine. So na ihlangana siyabona ukuthi asithi oratinate so 0.4 amperes plus 0.6 isinikeza ngaki 1 ampere. So therefore it means current flow kule parallel connection which is connected in series with the 5.8 is 1 amperes. Nangabe flow 1 amperes ngapha nangapha, it means your flow ngaki 1 amperes. So therefore sinayo current flow la, I can calculate V2. So now so asithi let's take out the data. Current flowing through the 5.8 resistor is what? Is 0.4 plus 0.6, which is equal to 1 amperes. Then see a resistance of 5.8 ohms. Now sifuna the potential difference V2, which is I times R. I is 1, R is 5.8. So therefore our answer is 5.8 volts. This is the potential difference across 5.8. Now 9.1.5, but to calculate the EMF of the battery. So for now the EMF of the battery. Okay. 9.1.5. The EMF is equal to V external plus V internal. V external, the external circuit in a potential difference yakhona nawihlanganisa na the potential difference inside the battery ikunikeza the EMF of iluganje of battery. So the potential difference in the external circuit is the potential difference measured across lana and the potential difference measured across lana. So nangihlanganisa V1 no V2, V external is equal to V1 plus V2, V1 plus V2, and then V internal is actually equal to current times the internal resistance. Now the internal potential difference now we need to calculate this one. This one is now V1 in calculator is 2.4 plus V2 ngam calculator as 5.8. Nangihlanganisa the two values ngithola u 2.4 plus 5.8 ngithola u 8.2 volts. 8.2 volts. The internal one is over 1 times internal resistance 0.8. Why am I multiplying by 1? Sitheni a series connection, current remains what? Constant. So bheka ke manje. The current flow la iyacombine la angisho divide la kule parallel connection nayihlangana la iba 1. So nayihlangana la, since the parallel connection and the 5.8 and the 0.8 ohms are actually connected in series kuyo yonke lelo kanye circuit. So no one oflow la kule parallel connection uflow la as well as lana. That's why I'm using 1 as a current for finding internal potential difference for the battery. So answer I am given 0.8 volts. So therefore the EMF is what? The EMF is equal to 8.2 plus 0.8, which is equal to 9 volts. So this is the EMF of the battery, 9.1.6. Excuse me. Now we need to calculate the energy dissipated as heat inside the battery if the current flows in the circuit for 15 seconds. For 15 seconds. So therefore I'm given time for calculator in the amount of work done. So let's go to the formula sheet. I'm given U delta T as 15 seconds. I also have data. Data yami nayi isaqhubeka data yami given okay. I have the energy dissipated as the heat inside the battery. So therefore resistance yami izoba ubani 0.8 ohms. I also have a current of 1 amperes. What else do I have? V as 0.8 volts. 0.8 volts. So now data in nine. Ngifuna ini the energy or the amount of work done. So therefore sifuna a formula. In the formula sheet is just needed to calculate the work done. But I think ngasebenzisa any of these formulas for work done. Any of the three. I do have current, I have resistance, I have time, I have volts. I have a potential difference, I have resistance, I have time. For this one I have potential difference, I have current, I have so any of the three. So sevens are the last one. V squared times T divided by resistance. is equal to, so no more sevens are any of the three. I believe we need to find, we're going to find the same answer, and we have to find the same answer irrespective. Go to 7, say which formula. So delta t is 15 seconds divided by r 0,8. Answer yami is 0,8 squared times 15 over 0,8. Our answer is 12 joules. Energy is calculated in joules. So this is the end of 9.1. So the second part of question 2, basipa another circuit. But a simplified circuit diagram for the windscreen wiper of a car consists of a variable resistor and a wiper motor connected to a 12-volt battery. A variable resistor. So now circuit abasipeona. So this is the source, a switch, a variable resistor, and a wiper motor. So this is the circuit for your wiper motor. Now basically, when switch S is closed, the potential difference across the variable resistor is, and the current passing through it is, calculate 9.2.1, calculate the resistance of the variable resistor. So I believe this question is going to be a straightforward one. So lana basiphe i-current basipha ne-potential difference. So let's calculate resistance. The formula it R V over I equal to, what's the potential difference? 2.8 divided by 0.7. So lana it's a giveaway nje. Nanga buflopile kulamanye ama questions ku 9.1. So lana kwamele uscore ke la. Lana kufanele uscore. So our answer is 4 ohms. Our answer is 4 ohms. 4 ohms. 4 ohms. Okay. Now the resistance of the variable resistor is now decreased. 9.2.2. State whether the speed at which the wiper turns will increase, decrease, or remain the same. Give a reason for your answer. 9.2.2. But the resistance of the variable resistor is now decreased. As big Ohm's law. Ama questions afana nalawa, you need to look at your formula and check the relationship of lama quantities ababuza wona. Angisho laba sibuza ngani speed. What influences speed in this case? Current, right? If there's more current flowing, le motor yethu izotena kakhulu because there's more energy being deposited or being transferred by the passage of our electrons kuleyo device, kuleyo component. So it means that if there's more energy available for imoto yethu ukuthi isebenzise. That's why izotena kakhulu if there's more current flowing. Now, if there's more current flowing, the speed will increase, right? So check out the relationship. What is the relationship between resistance as well as any current? So using Ohm's law, I can see that if naibala, so I equal to V over R. Why? Because this is the factor or the quantity abai change. But the resistance of the variable resistor is now decreased. If it decreases the resistance, now what's going to happen to the current? Current is increase. So therefore, state whether the speed at which the wiper turns will increase or increase, decrease, or remain the same. So decrease in current in resistance there's going to be an increase in current, and an increase in current means what? An increase in speed. So therefore speed sethwenzani sizo increase. Bese bathini bathi give a reason for the answer. Siyabona from Ohm's law and a decrease in resistance, a decrease in resistance will increase the flow of current according to Ohm's law. So therefore, why? Because resistance is inversely proportional to current go Ohm's law. So therefore, an increase in current, just like what I was explaining regarding the rate at which of electrons are passed through the component. It means if there's an increase in current, there's going to be an increase in the speed of the wiper motor. Angifuna ukuyiqedelela because lana when answering questions, there's no like one way of answering it. It's the way, like the key words la ukuthi ustate ukuthi there's a inverse proportion relationship between resistance as well as current. That's the main keyword or the main phrase okumele uyisebenzise when answering this question. So uma usebenzisa leyo phrase leyo, you just building on top of it or building the argument yakho from that phrase leyo, right? So yeah, ivideo yethu izophelela lana. I hope le video we enjoyile, and then now we enjoy, please leave a like. Now with a question, let's talk in the comment section. Consider subscribing now we're new to my channel. Now we enjoy content yam, please share nabangani bakho asibonane kule video elandelayo. So thanks for watching, and ungakhohlwa uzothola ama links for amanye ama questions for this question paper. So thanks for watching. Bye bye.